I was fighting the weekend, but I was I remember. I do that half the team. That's what I was. Yeah, four. It was the five.
Are you going to that?
So I always spend more time on factoring than my counterpart in Pine. Mr. Walter over in Pine and we teach the same thing, and we vary in unit one as to how much time we spend. I just spent 6 weeks, but I'm happy to do it because factoring is one of those things that's going to pop up kind of throughout the year. So I do. I wish I could accomplish all of that in 4 weeks. I just don't know realistically looking back that that's something I could do. So anyways, the next push for this unit shouldn't be any troubles for us. The goal of unit one isn't to teach you how to factor. The goal of unit one is to teach you how to solve polynomial equations or to figure out stuff about polynomial functions. Like when we graph a curve, trying to figure out where it touches the x-axis is a big thing. That's a big thing in every level of mathematics from this point on. So what we've been doing is learning how to factor so that in time we can find zeros. They're called zeros of polynomial functions. So factoring in and of itself is a waste of time. Just sitting around factoring is yay. But then applying it to polynomial functions is the reason that we need you to acquire that skill. So that's going to be the push for the rest of this. There are a couple different ways to divide polynomials. One of them is called long division. I'm going to save that one. Maybe for tomorrow, depends. But I wanted to warm us up with the easy version. So what we're going to do is we're going to take, and I wouldn't write this down if I were you. I'm just going to show you kind of what you're up against here. So you're going to take, and again, don't write this down because I have no idea what the answer to this would be. But what we're after is, can I take this, a polynomial like this, and divide it by a polynomial like, say, this? So the reason we do this is to test for zeros. We want to know if something is a zero of a function. In other words, if a number is a location on the x-axis where a snaky curve pings the x-axis. Every time something happens with the graph, we're very interested in where it crosses the x-axis because that's where a function takes on a value of zero. And so by dividing like this, we can check and see if certain numbers are where the graph crosses the x-axis. So this is where we're headed, is starting either tomorrow or next week. We're going to do long division. I will caution you ahead of time that long division is kind of a little rough. It's not super difficult per se. It's just a lot. It's a lot of like detail-y sort of stuff. So provided that you have good basic skills and that you're not prone to, oops, I forgot a negative, like LOL. If you're one of those people, this will always be difficult, everything we do. But if you're good at like organization and not making little mistakes, you won't have any difficulty. It's just a lot of work, okay? So what we're going to do today is a different version of division. It's much simpler than long division. It's called synthetic division. Synthetic division only works when do you guys know what a divisor is? If I say like 12 divided by 4, do you know which of those is the divisor? 4 is called the divisor, right? Do you guys know what 12 is called? The dividend, right? And so when you do a division problem, you have a dividend being divided by a divisor. And do you guys know what the answer is called? I mean, it's 3, but like, what's that? There's a name for it. It's called the quotient. Very good. There are 4 parts to every division problem. There's a dividend, a divisor, a quotient, and then sometimes if it doesn't come out even, what's that 4th number called? It starts with an R. It's called a remainder. So those are the 4 key components that you're going to see in today's lesson: a dividend, a divisor, a quotient, and then about half the time, a remainder. All right. So that's the vocabulary of it: dividend, divisor, quotient, remainder. So let's just get right to it. I have a 6 examples here. and they're all chosen for various reasons. So the wording on your Delta Math assignment is going to say it's going to look a little bit different, and I'll show you an example of that. But at the end of the day, what the program's going to ask you to do is take a polynomial like this and divide it by a polynomial like this. So synthetic division is only possible. I'll let you write this down and then I'll say this just so I don't have to say it again. The type of division you're going to learn today, you're going to like it, actually. I mean, that's weird for me to say, like people go, yeah, whatever. You're going to actually enjoy the process of what we learned today. It only works if the divisor is linear. Okay, so the people say, like, why can't we just do synthetic division all the time? And the answer is, well, you can't if your divisor is a quadratic or a cubic. And it doesn't work very well. It's super difficult if there's a number in front of x also. So really what we're looking for here is, and this has a real super sweet big spot in mathematics, is we're also looking for there to be no number right there in front of x. So all of our divisors today are going to be x minus 2, x plus 5, x minus 4, stuff like that. Okay, so our divisors are in a little pocketed specific kind of group here. All right, so let's get to it. What I want to know is this. I want to know if I take this big, long, 4-term cubic polynomial and I divide it by this little itsy bitsy linear binomial, what will the quotient and the remainder be? So let's get to it. This is how you set up synthetic division. Step 1 is you take the numbers off the front of your dividend. And I'm going to point to all of them with purple arrows. Okay. And we're going to write them down. So the coefficient, that's the word we use in math to refer to numbers, the number part of a term of a polynomial. So 4 is going to go first. What's the second coefficient? What's the number in front of x squared? There's a 1 there. You just can't see it, right? And then after that is the linear term, -10, and then the constant term of -16. And you're going to be doing a lot of this. So here it goes for the first of about 75 or 100 times. You're going to make an upside down division sign, a long division sign. And you're going to leave room where I'm moving my pen right now. You're going to leave space there and you'll see why. So what you do is you build an upside down division sign like this. And then you come across like this. And again, you must leave space there for reasons you'll soon understand. Now, what we're going to do, the process of synthetically dividing is actually also called synthetic substitution. What we're going to do is we're going to ask ourselves, what makes that green underlined quantity equal 0? What could you put in place of x to make that small parenthesis equal 0? 2. Therefore, we're going to synthetically substitute the number 2. To perform synthetic division, you're actually performing synthetic substitution. What I want to know is, does something cool happen at the number 2? And this will all make more sense in a few days. If today you kind of feel like, I don't know what's going on, just learn the algorithm, the process today, and let's master this before we get into the conceptual stuff. So again, some of you will memorize it as though, so I take the opposite. And it's like, yeah, if that's, yes, whatever. So +2 is going to be my synthetic substitutor. And here goes the algorithm. To do this, all you have to do is memorize a few steps. And it doesn't take long. Step 1, drop the first coefficient all the way down underneath the division sign. Go for it. The second step in the algorithm is to multiply your substitutor by the new number that you dropped. So what is 2 times 4?
8.
So you will put an 8 right here. And it's right here now that the algorithm begins to repeat itself. We're going to take 1 and 8 and we're going to add them together. What's 1 plus 8? And you're going to drop that down. 9. And you're going to now continue to rinse and repeat until you've reached the end of the division. So what is 2 now? Always go back to your substitutor, right? The one out here where I'm moving my pen. 2 times 9. Put that there and add. -10 plus 18 is 8. And repeat. 2 times 8, 16, and then add. And what is negative 16 plus 16? 0. What I always want you to do is put a box around this one. I've really rarely been bossy about this, but I've learned as I get older and wiser that having you do that is going to help you a lot. Me, whatever. You, it's going to help. So that number in the box is the remainder. And what this means, and you've known this since fifth or sixth grade. You now know that when you perform a division problem, if there's not a remainder, it means that the divisor is a factor of the dividend. And I can apply it to like fifth grade math. I'll just write something off here to the side in red. What's 24 divided by 3? It is 8, and there is no remainder, correct? So we say then that 3 is a factor of 24. That's the definition of division. In fact, this is called the remainder theorem. If you divide two polynomials and get a remainder of 0, the divisor is a factor of the dividend. Okay? So how we write our answer now is always going to be like this. I'm going to write this in purple. It's going to be Q plus R over D. We know what all three of those letters stand for. What does Q stand for? Quotient. What does R stand for? Remainder. And what does D stand for? Divisor. Let's understand something, that if I changed my division problem up here, do you see kind of where I'm about to erase up here in the corner? If I change that division problem to be 24 divided by 5, you don't get a whole number, do you? How many times does 5 go into 24? 4, with a remainder of 4. So in a case like this, you see I've got quotient, remainder, divisor. 4 and 4/5 is the same as 24/5. That's how we're going to write our polynomial answers. Now, in this case, since the remainder is 0, you don't even need to acknowledge its existence. The plus R over D part, we don't put. Like if I said to Coulter, hey, Coulter, what's 24 divided by 3? He wouldn't be like, 8 and 0/8 or whatever. He wouldn't do that. He'd just say 8, right? We ignore the existence of a remainder if it's a 0. So all I'm going to do now is I'm going to drop the power. Pay attention to the yellow pen. Do you see how that's a 3 up there? Drop it by 1 and start writing a polynomial. So it means that this is going to be 4x to the 1 less than what you started with. What's the second term going to be? Plus 9x. And what's the last term going to be?
Yeah, plus 8.
Done. You can put a box around that. That is the answer. That means that if you divide 4x cubed plus x squared minus 10x minus 16 by x minus 2, you will get an answer of 4x squared plus 9x plus 8. Dividend, divisor, quotient, no need for a remainder. I'm guessing you didn't enjoy that one. Let's go again. Eventually you'll catch the vibe with synthetic division and you'll actually kind of go, I like this. And maybe not all of you, most of you.
So it'll serve the X and it's the remainder.
Say again, buddy.
So if like 16 says didn't start with an X, it's the remainder. After you did the,
Are you talking about this column?
yeah.
Your last column will always be the remainder column. And you're right, it has no X's. That's like our constant column. If it had come out to be like a 3, which of course several of my examples today will. I think I made the second one also without a remainder, but then we're going to start seeing and I'll show you how to write that down. Okay. The second one, let's do 2x to the 4th plus 13x to the 3rd plus 21x squared minus 3x minus 18. We're going to divide that by x plus 2. So what's step 1? But before that, I need a little bit of structure to hold it together. Copy your coefficients, correct. And so these numbers, I'll underline them in purple. These are going to be the numbers that we're going to copy down. Okay. So my coefficient row is going to be 2, 13, 21, -3, -18. And then you're going to draw your upside down division sign. And what's going to be my substitute number on the outside? It is not 2. It is -2, because you have to remember that we're trying to make the divisor equal 0. And we're off. Be ashamed to make a mistake that early, right? It's kind of like shooting yourself in the foot before you even get going. I got to make sure he's not here before I make jokes like that. So there we go. Drop it, and we begin. Next step. Multiply diagonally. So the red number is going to be a part of everything that we do for the next 30, 45 seconds. So what is red number times bottom? -2 times 2, -4. 13 and -4, add them up. Drop a 9. Multiply again. -2 times 9, -18. 3. Multiply again. -6. Add -9. Multiply again. 18. When we get to the portion of this unit next week, when we start really caring about that remainder, that's going to be something that you will treasure. Mark my words. There's going to come a day, ask anyone who's taken this class before, that they'll tell you that when synthetic division comes out with a 0, that means that you have found a 0, a root, whatever you want to call it. It's a big deal. So anyways, example number 2, I guess as advertised, I wanted to give you another one without a remainder so we could just practice the algorithm. So to write our quotient, our final answer, what's our first term going to be? 2x to the 1 less than it started as. Good for you. Remember, up at the very beginning in the dividend, we started with 4th degree. You always go down 1. Since you're dividing by 1 degree, that's why you take away 1 degree. What's the second term going to be? Plus 9x squared, third term?
Plus.
Correct. Fourth term? -9, box it up. That is it. And that, honestly, that quotient isn't so much what we get excited about, we math nerds. What we get excited about is the 0. The 0 means something cool is happening on this graph when x is equal to -2. That's what we get excited about. Okay. Are you prepared for round 3? Remainders are going to start showing up I don't remember if it's this one or the next one, but now they're going to start popping in. So let's do 2x to the 3rd plus 14x squared plus 19x minus 8. That's our dividend and our divisor. Anyone want to try to guess the divisor just for fun? Nope, it's x plus 5.
Yeah.
You can try again on the next one. Your chances aren't very good. I mean, they're like 10%-ish. Wow, 5%. 8%. All right. You ought to be feeling like you're ready to like cook. So let's get in here. What step 1? Pull your numbers, pull your coefficients off the dividend. And they are just, again, I'll underline them for you, 2, 14, 19, -8. So we're going to write those down. 2, 14, 19, -8. Draw your upside down division. Remember to leave room for the worky numbers. And what's going to be our guy on the outside? -5. That's the setup, and now we just roll through it. Drop the 2. By the way, this whole dropping thing isn't really like, I don't want it to be a mystery. Technically, there's like an invisible 0 here, just FYI. So like we are adding 0, but just most math teachers aren't going to phrase it that way. Most math teachers would just tell you to drop the first number. It's easier that way. And we begin. Multiply, add, multiply, add, multiply, add, multiply, add, like over and over again. So what's our first multiply? -10, add. 4, multiply, add, multiply, and we have a remainder. So for the first time now, we're going to have to acknowledge that our answer needs to not just be a quotient, but our answer needs to be expressed as a quotient plus a remainder over a divisor. With the remainder not being zero, I can't just ignore it and act like it's not there now. It's a big deal that he's got one. Let's talk about what it is. So to write our answer, we're going to follow the same thinking. We're going to start with our first term. This 2 that I'm drawing the yellow arrow down off of is our starter. He's going to be 2x to the what? 2x squared. Because we're dropping by 1. What's our second term going to be? Plus 4x, our third term, minus 1. And to keep your lives as simple as possible, rather than worrying about the difference between plus and minus, let's just adhere to that yellow egg and be very literal about how we interpret that. We're going to just put a plus right here and then draw a fraction. What's the remainder? So we put -3 over the divisor. What's the divisor? Nice. Good job, Nick. Eventually, you will, once you exit like the newness phase of this concept, you will get into the phase where you ask questions like this. Can I replace those 2 red signs with just a single minus sign? And the answer is, yeah, you can. So I don't know, like at what point you become comfortable doing that. If the answer is never, then don't ever do it. You always do it like this. But if at some point if you're like me and you don't really like a plus and negative kind of thing, then you could follow the little eraser here. You could make this just minus and then call your remainder 3. It's not technically 3. I mean, it's just by putting a minus there. You know that subtracting 3 is the same as adding -3. So you choose. And when you type them into Delta Math, I'm pretty sure you could go either way. Like, I doubt it would care. Any questions there? All right, let's go again. Round 4. Quotient plus remainder over divisor. Here comes round 4. We have 3x cubed minus 17x squared plus 13x plus 23. We're going to divide. Okay, it's your chance. You get to try to guess the divisor. What a fun game. It is x minus 4. Jackson wins the closeness award, which there isn't really an award for the record. You should be ready now to not talk too much about this. There's almost a 0% chance that you don't know what to do. We're going to copy the 3, -17, 13, 23. So let's do it. 3, -17, 13, 23. Upside down division. What's my number on the outside? +4. And we smoke through the algorithm. You can see that this will be a little bit harder for those of us that struggle with basics. I wish it weren't a reality in 11th grade math, but it still is. So, you'll be slower. You have to accept that. If you struggle with times tables, when is the answer a negative, that kind of garbage. So drop the 3 and we are off. What's the first answer? I didn't see that one coming. 4 times 3 is 12. -17 plus 12. Now I'm ready for you. There's that -5. 4 times -5. -20. Add them together. -7. Multiply them together. -28. Add them together. -5, which means we do not have divisibility, which means we do not have a 0. It's okay. We're going to practice today writing Q plus R over D. So here we go. Let's write it as Q plus R over D. What's our quotient going to be? Quotient is built by these numbers. What's our quotient going to be? 3x squared minus 5x minus 7. And I'm just going to keep it normal as plus. And what's going to go on top? -5. What's going to go on bottom? And that is Q plus R over D, quotient plus remainder over the divisor. You would think to yourself, this would be a logical place for a math teacher to say, I think you get it. These last two examples serve a very, very specific purpose. Any questions about that one? All right, let's get to it. This next one is going to be 4x to the fourth plus 6x to the third minus 15x squared plus 1 divided by. Anyone want to guess the divisor?
-3.
Wrong.
Oh,
You had the minus. What's step one? Take your numbers out, and they are going to be 4, 6, -15, 0, and 1. I saw some heads shoot up from papers as if to say, did my math teacher just have a stroke? What just happened? The reason examples 5 and 6 made the cut is because oftentimes your polynomials will be incomplete. They'll have holes in them. And, I think I could have made this more obvious perhaps if I had scooted this like this. And then maybe you would have seen that there is a glaring void right here. What you need is continuity. You need your exponents to go 4, 3, 2, 1, 0, or 5, 4, 3, 2, 1, 0, or 2, 1, 0. You cannot have gaps in your synthetic division. So I inserted a 0 because there is a term here that you cannot see, but we have to acknowledge, and that's a 0x. That would complete the continuity. That would ensure that my exponents now step down one at a time. 4, 3, 2, 1, 0. Are we clear? When there are missing terms, fill them in. What's our number on the outside going to be? Positive 1. We're trying to make this thing, the red egg, equal 0. -1 would just make it worse, -2. Positive 1 is our guy. We are synthetically substituting the number 1 now to see what happens. And here we go. Drop the 4, and we are off to the races. 1 times 4. Okay, good. I'll get this one. I'll do the heavy lifting, guys. 6 plus 4. 10. 1 times 10. 10. -5. -15 plus 10. -5. 1 times -5. 0 plus -5. -5. 1 times -5. -5. Add them together. -4 is our remainder. So what's our quotient going to say? Boom. Just like that. Quotient plus remainder. Round 6, and this will be the last one. Took a little longer, but teaching math always takes longer than I think it should. So here we go. 3x cubed plus 4x squared minus 23x divided by, you guys get one more chance to guess the divisor. Let's go.
X minus 7.
X minus 2.
Ah,
This game's harder than I thought it would be, but really, if you think about it, you do have, thinking that I'd keep my numbers between like -8 and 8. You got a 1 in, what is that, a 1 in 16 chance?
yes.
Those are not good odds. All right, let's play. Let's go. So pull down your numbers, right? What are my purple numbers going to be? 3, 4, -23, 0. This example exists, bless you, Jack. This example exists to inform you the answer to the question is yes. Mr. Aaron, do I need to put a zero if it's at the end of the dividend? Yep. Anything that prevents the continuity from highest to zero. We got to get all the way down to a constant. And in this case, since there's no number in the back, we think to ourselves that there is. And again, I can sort of illustrate that for you. If I grab all this stuff and pull it out here, then I can show you that to get this polynomial to be actually complete, there is a fourth term that you just can't see. So these two examples serve the purpose of showing you how to insert zeros. It will not work if you miss your zeros, FYI. I think you might stumble onto one occasionally. I don't know if that's even possible where it would work. I don't know, but don't do that. All right, what's my outside number? Positive 2, drop the 3, and we are off. 2 times 3, 4 plus 6, 2 times 10, negative 23 plus 20, 2 times negative 3, add them up, negative 6. Boom. Quotient plus remainder over divisor. Jackpot. That, my young friends, is how you perform synthetic division, right? I don't think there's anything in there that I have not included. Famous last words, but that is how you do the process. You have an assignment. It's going to be in Delta. We do have 4 precious minutes left. Let's utilize them. Get your Chromebooks out. Let's at least pull up the assignment. Let's get out the scratch paper we're going to use, and let's see if we can let's use this time as well as we can. See if we can get a problem done. You will have class time tomorrow to work on this, obviously. But let's all get a problem done. Or 2.